All right, here we go. So good morning. Welcome to our second workshop in our series. My name's Daniel. I'm one of the mentors of 14380. I'll introduce our team.
I am Andrew. I'm one of the coaches of the team.
I am William. I'm also one of the mentors of the team.
I'm Rylan. I'm one of the students of the team.
I'm Nick. I'm a second-year student.
Hello, and I'm Ryan, and I'm a third-year student of the team.
Awesome, thanks guys. So today's what we thought we'd do is we'd get in and we'd start talking about some of the mechanisms, the designs, some of the prototypes, just some of the learnings that we've had over the last week, and share them with you, and some of the equipment that we might be able to use to help build your robots this season. So I guess the first thing, guys, what do we want to talk about? Maybe how you potentially need to launch these elements. So do you want to start off a bit of a discussion? Again, guys, if you're out there, just drop a note into the discussion. If you've got any questions, and we'll try and answer them. So do you see that comment that someone's put there? It says, for best viewing, set your viewing to speaker mode. Oh, that's us. Okay, awesome. No worries. Whoops. Anyway, so yeah, do we want to start talking about launching these elements? So obviously, we've got to get them into the goal. So there's a certain height that we need to be able to get them up from. There's two different zones that we can shoot from, or launch from, and the larger launch zone and here at the back of the field. So obviously there's a little bit of different energy requirements that are needed to get from one zone to another zone. Nick, do you want to talk about, we've put together a little bit of a prototype. Hopefully Jack can come in here with the camera in a sec and we can have a bit of a closer look at how this prototype works. Do you want to describe how it works?
Yeah, right. So this is our one of our first shooter prototypes, or launcher prototypes for the season. So it's like heavily inspired on the Robonauts 2017 Steamworks shooter for the fuel. So Jack, can you have a top view? Thank you. So how it sort of will work is the artifact would come up from underneath, go past through this ramp, and we've got a Go Builder Rhino wheel here that is powered by a bear motor with a pulley from 18 to 25 to 18 tooth. It's for heaps of speed, so that'll be upwards of 7,000 RPM for lots of speed. And then Ryan can show you that there's got this little hood here, so that can change the angle that the ball will go out. So yeah.
Yeah, so I guess one of our early discoveries was that we started looking at some of the compliant wheels, so these Go Builder wheels that Ryan's got in his hand just here. There's a pretty interesting, I guess, effect that happens when one of these wheels is spun at really high speed. Do you want to talk about the wheels and what happens when we start spinning them?
Yeah, so a problem you might encounter when you spin these really compliant wheels is that they actually expand. And so when they expand, they decrease the consistency and reliability of your launch every time. So I think it's because when they speed up, one, they stretch out, and two, they also can heat up a lot from the constant artifacts going through the launcher. Yeah, and so if you look at this prototype, for example, we had a problem with the compliant wheels where this one would expand and start touching the motor, and it would rub on that motor and wear it down. So that's something to be careful of, and that's why we're using the Rhino wheel here, because it's not very compliant and it will keep its shape fairly well during the game.
So yeah, just in terms of hardware, I guess the Rhino wheel from Go Builder is what we've found to be quite good at this point. But they do have the same kind of texture as what the Rev traction wheels do from the Rev starter kits as well. So these little guys, they're quite firm and they don't expand out. I guess Nick mentioned the bear motor. We've got a bear motor just behind Ryan just there. Do you want to grab hold of it? Because I think this is an important distinction. Thanks, William. So these motors, they run without gearbox. So you mentioned before about the 7,000 RPM. Nick, do you want to talk more about the importance of why you use a bear motor?
Yeah. So the thing about a bear motor is that because it's in the simplest form, it's a yellow jacket with no gear ratio on it. So it just spins really fast. And why you want to use one of these is because you need a lot of speed this season to launch the balls out of the launcher into the goal. Yeah. Do you have anything to add?
Yeah, absolutely. Thanks, Nick. Yeah, so really important that you get back to that best speed. Now, Nick had one of the yellow jackets in his hand, but basically you can also use a Rev ultraplanetary gearbox just with the output stage on it. So that would give you the same as like a 1-to-1 gear ratio, effectively. So what you might find is that without going to that higher speed, you just don't get the purchase and you just don't get the speed coming out of the launcher to be able to really propel the artifacts. So another interesting aspect that we've discovered is as these motors, they don't have a lot of torque. So when the artifact does hit the flywheel, it will change in its velocity or its speed. So something that you might want to have a think about. Did you want to have a chat, William, maybe about what the importance of something that can help us keep that speed consistent?
So to try and make sure that our bear motor has the consistent speed for consistent launches, and we may want to consider some way of continuing that momentum. So if you look at previously FRC games have similar type of problems and the solution they come up with. So like an example is a particular flywheel, like a metal flywheel, so that they have most of the mass at the end of it, so it keeps rotating and the momentum keeps rotating. So that's how you could solve it. You could also just consistently wait to do so you don't do your rapid launches. So that's another way so that you can get those consistent launches as well.
Cool. Yeah. So for consistency, maybe look at adding some counterweights that help absorb some of that energy losses as the artifact goes through the flywheel. The other thing I guess we've got on the top there was we kind of alluded to the little hood there. Do you want to talk through what the purpose of the hood is for, Ryan?
Yeah, so some challenge that some teams might want to go for is being able to shoot from varying distances across from the field. And so to do that, you need to change the power and even the angle that the artifact is launched from your robot. Because if you're launching from right next to the goal, you're going to have to shoot a lot higher up, while from back here, you're going to shoot at a lower angle. And so that's what this hood is for. There are multiple variations of how you can make what's called a hooded launcher, but the main premise is something that can change the angle of the launch. So here, when the hood is positioned up here, the ball will just fly out and just go straight up. But if we change the position of the hood to something a lot lower, it will fly out at a lot flatter angle. And that will help teams be able to shoot at different ranges. So if you want to be able to shoot at this triangle here, but then also want to shoot from that launch zone over there, you're going to need to look at a hooded launcher in order to change that trajectory.
Thanks, Ryan. So if we work our way down a little bit from the robot, if we consider that we're sort of starting from the top, we're looking at the launcher. The launcher could obviously be directly attached to your chassis. Sorry, attached to your chassis. But some teams might consider, well, it might be beneficial to have the launching mechanism be able to move and even potentially follow the target all the way around. And I think Nick's just grabbed hold of a piece of equipment that I'll let you have a chat about what this is, Nick.
So this is called a lazy Susan bearing. So what it does is, if Rylan wants to can demonstrate, it can. So if you make one of them rigid, one of the sides rigid, or one of the rings rigid, the other one's able to spin. And if Jack, you want to have a look at this robot over here, you can see an implementation of how we've done it as a prototype. We've got it done geared from chain from a yellow jacket motor that's able to spin. So that could be beneficial, having your launcher on a turret so it's able to track the goal or even rotate to the goal, so your whole robot chassis doesn't need to move to angle.
So conveniently enough, the artifact will fit through the center of this lazy Susan bearing. So you want to talk about some of the aspects?
The lazy Susan bearing can actually, the same type of model, I believe, can be bought from Andy Mark as a robot's kind of bearing. So yeah, it's to note with it, if you put too much pressure from the inside of it, it may bind up. So it's difficult to show, but if you kind of put too much outwards force onto it, it could bind up and you could face issues. And then there's the other aspect is you may want to put a certain camera onto this so that you can try and track the April tag of the goal. So there's always cable management to worry about, and then there's just the type of camera you're going to use. So
Yeah, awesome. So just to note these, so if you're an Australian team, these can be purchased, I think, on eBay. I think some of these were bought off of eBay. So I can't remember the price. They're sort of less than $50 though. The alternative is like if you're looking at a proper engineered approach, it would be like a contact bearing, so a large contact bearing. They can be kind of upwards of over $150, and they're thinner and lighter. So this weighs about, I think, about 350 grams or so. A contact bearing would be more in the sort of the 40 to 50 gram range as well. All right, so we've kind of talked about, I guess we'll stop for a sec. Does anyone have any questions about the potential launcher that we've sort of shown? Obviously, there's more ways to launch than what we've shown. We're sort of just showing a hooded launcher. There's the other potential to use a handful of different flywheels. So, yeah, Nick's sort of saying, yeah, we can go from either sides. I guess there's some disadvantages to that. Do we want to kind of touch on that for a little bit around what it might look like to use two wheels instead of one? Are we happy to have that discussion, do you think? Yeah? Who wants to have a chat about that? No, you can do it. Yep.
So, what we do with this prototype that we showed before, we're using one bear motor for the launching, but you could do two sideways. But there's a slight issue. You could face issues with that, with the motor limits. So if you do it to the side, it will probably still cause the artifact to launch into the goal, but you could be using up two your bear motors instead of one, which you may want to use that motor up in somewhere else. But it could also induce some type of unnecessary spin to the artifact as well. So you could have the side spin depending on what kind of way that you want.
Yeah, excellent. And that's actually an important aspect to consider. So our launcher here at the moment, it's going to impart some backspin on the artifact. So as it comes out, oops, sorry, Nick. It's going to be rotating actually this way. Yep. And then what happens is it's going to come along, and the plan with it being rotating backwards is it's going to hit the back of the goal and then rotate into the classifier. So that's the design for what this particular one does. So it is, and we have done a little bit of experimenting. We have found that the spin does have a noticeable impact on the way that they roll into the classifier. In fact, it's probably possible to put too much backspin onto it and to have it come back a little bit too quick, potentially, as well. So something to really test and prototype. All right, oh, sorry, Ryan's got a design over here that's another little prototype. Do you want to hold it and talk?
Yeah, okay. So this one here is another launcher prototype. This one is the two side wheels that we were talking about earlier. You can see it's this one is powered by one motor. Is possibly you could counter rotate this one with the same motor, or you might use two motors, like William said. And that's where again you might get those spin issues, because if one wheel is turning slightly faster than the other, then it will start spinning sideways, and it might spin differently in the air, or when it hits the goal, it might bounce in an unknown way. And if you're trying to, for example, score motifs, then it might not go down the classifier in the same order you shot it in if you have some strange spin.
Excellent, thanks. So far, no questions. That's okay. Excellent. Yeah. So we talked about the launchers, the turrets. Now let's get to the part where we can start talking about, well, housing all of these artifacts that we're collecting up. What's some of the ways that we can kind of store them? Because the storage limit this year is 3, and these are quite sizable game elements, particularly for FTC. So I think Ryan's got a linear sorting or storing mechanism. So what we're looking at here is basically, I think it's pretty close to the minimum size that you could probably have if you wanted to store all of these artifacts in a straight line. So I think, yep, he can kind of load them in. They kind of go into each of the different slots, and that's about as good as we can go. And if you have a look, remembering our field has basically a sizing box on it. If Ryan were to put that down just there, you'd see that that takes up a huge chunk of what your robot size would look like. So I guess there's, so obviously that's in a straight line. There's obviously ways to be able to store that on an angle, which would give you a little bit better, I guess, packaging. And Ryan, do you want to, Nick, one of you guys, you want to talk through the other packaging options that we've got? Yeah, cool.
Yep. So I'll let Nick load it up for me. But the other, kind of option you could do is kind of in a triangle formation, kind of like this. So in this method, if there's a camera who wants to see it, in this method, the artifacts are grouped a lot tightly together. And if we come and bring it down to the base here as a size, it's a lot thinner in its width, and it also doesn't extend as far. If we compare it to the linear kind of version, while the linear one is thinner, it does take a lot more vertically. So it depends kind of how you want to store it. And then the next question from there is how are you going to get the artifacts out of your kind of storage system. So yeah, and actually there is one more option, and that's if you don't not necessarily going for a ground intake and want to do kind of like a human player intake, there's also the kind of vertical version of this linear storage system, where a human player in the loading zone can place 3 in a linear cube like this, and then it can feed like underneath and into a launcher, for example.
Excellent. And we had a bit of a discussion about this yesterday, but we think this year the human player loading is actually still a very valid game choice or design choice. The only thing that they miss out on is a little bit of that ability during the autonomous period to really maximize their scoring. But that's not to say that they can't make it back up this year. With the way that the autos are scored at the end of auto and at the end of teleop, there's still big opportunity for you to really make gains during the teleop period. So if you're very, very quick in that teleop period and you've got a really rock solid, reliable system that can be loaded up from the human player, you could potentially do very, very well with that. So like Ryan said, that storage system, have a think about what might suit your robot's needs. But obviously you get a little bit of an advantage if you're going for the ranking points. You're probably going to need to do some sort of sorting at some level. You don't need to sort for the whole autonomous period, at least a few of them, but you will need to have some sort of sorting capability to do something at the end of the teleop period. Yeah. All right. So the next thing, I guess, is we've looked at the top, gone down to how we've stored them, got to get them into the robot. We don't have any prototypes around the intaking at this point, but we do have a bit of experience doing some intaking before, and I guess there's a couple of different ways to go about intaking. There's a bit of a debate, I guess, counter roller or no counter roller. What are our thoughts? I'll go around the room for this one.
Yeah, so I'll just start off with some observations. The artifact is a ball shape this year, so it means that a counter roller is not as necessary in my opinion, because it's already rolling and will be able to roll up ramps or any other way you're intaking it.
For me, it sort of kind of depends. If you want it to be like super quick, like lightning fast, then you'd probably use a counter roller, but you might not need that and you might just need the top, so it's kind of depends.
Yeah, as Ryan said, I personally would rather use a counter roller just to make it a bit faster and probably more reliable, but it's not necessary, so you don't have to.
Yeah, in my opinion, I think it's viable both ways, counter roller or no counter roller. I think we'll definitely be seeing both variations.
Yeah, I think that's a good point. I think both the counter roller and the no counter roller will be both viable in high level play. I think the counter roller would provide more of a kick upwards and probably a little bit faster, but at a certain point the difference between it will be negligible.
Well, I believe that the counter roll is necessary for certain types of intakes. If you're intaking from the top, I would say a counter roll is necessary, but if you're intaking from the side, probably not necessary.
Yeah, And I think there's probably other aspects that are involved as well. Is your intake full width? Does it go across the front of your robot? Is it impact resistant? That's something that's pretty huge at this point as well, because we know that there's going to be a lot of defense. We think that there's going to be a lot of defense. Oh, we've got a comment from Load. Hey, Load. What is a counter roller? Oh, we lost our connection when we explained. Oh, okay. Does someone want to talk about a counter roller? Yeah, go for it. What? Okay, Nick. Yeah, if you like. Yep.
So
I can try and, or Ryan can potentially kind of demonstrate if you like.
So you can sort of imagine with how a counter roller works is that, so if you have a top-down intake, so you've got a roller on the top that's spinning in a ball from the ground, but so that would work fine if you were just going straight through your robot. However, most likely you will be going upwards a bit, whether it's to get to your launcher, into your indexer or anything like that. So what a counter roller does is a counter roller provides a way so the artifact rolls in and the counter roller sort of kicks it up off the ground and gets higher up into the robot. That's good.
The way we can power because it's in the opposite direction, we can actually do some sort of inverse O-ring. So kind of go downwards and do a figure 8 aspect so that you can kick it up. So you're using the same motion from your top roller into your bottom roller.
Yeah, so I guess just to sort of iterate on that again, basically you've got a roller that's spinning in one direction, which is the main intake, and below you would have a smaller roller, which is going in the opposite direction, and because it's spinning in the opposite direction, it has that kicking effect, and as that kicks it up, it's going to push it into the roller that's coming around at the top and push it in. And like William was saying, sometimes getting that opposite direction can be a challenge from a design perspective. So he was suggesting that you could use a belt that's shaped like a figure 8, and as the rotation at the top spins, it's going to naturally spin it in the opposite direction to the bottom. So those figure 8s can give you the power without having to do some fancy stuff.
Well, we did something similar to that in Center Stage, where we had an inverse O-ring that did the counter rotation. So if you want to watch, we have a behind the butt that describes what we did back then.
Yeah, awesome. Thanks. So we've got a few different types of options, I guess, for our intake. Ryan was just using some Gecko wheels from GoBuilder, but they're not necessarily the only option. There's a pretty popular open source tool that's around now called Optake. Does someone want to talk about what Optake looks like or what it is? Do you want to do that one?
I'm going to go get
one. All right. Oh, you're just going to go and get one. Excellent. All right. Do you know what? No. So Optakes are basically it's an open source component that lets you put surgical tubing on it. So they're basically little nubs that the surgical tubing can get cut onto and placed on it. So there's Andrew's coming over here now with one of our older prototypes for these things. Yeah. So they're pretty popular, and I think there's a command in the FTC Discord, just like Optake, and then it'll send you the links. Yeah, ! Optake. Yep. So what we found, if you do use surgical tubing, there's different types of grades of surgical tubing. The sort that we've used in the past that has been excellent is what we would call surgical grade tubing. It's a little bit more expensive, but it's really, really strong. So you can almost cut the ends, or you can cut the ends of the surgical tubing. You can cut a little strip off, maybe 10 centimeters or so, and put little cuts in the end. And because it's such good quality, it will still have little parts that come off it, but it won't split and it won't cut, or it won't break any further. What we found is if you use the small, like the poorer quality surgical tubing, say potentially like for fish tanks or aquarium usages, it just doesn't have the durability. It just doesn't have just the motion that really makes it really nice. So if you're in Australia, you can get it from a place called Surgical Direct or something like that. And it's in Western Australia. It's about $30 a meter. It is expensive, but it's absolutely worth it. And it can be used for multiple years if you're careful with it. But yeah, so that's one option. So we talked about the Gecko wheels, the Optake. Yeah, the little boot wheels from GoBuilder is another option. If you're inspired by Vex, we've also seen some rubber band intakes and that sort of stuff as well in the past as well. All right, how are we going? Questions? Anyone? No? Sorry, what was that?
Talk about intakes that couldn't.
Yeah, all right. So we've talked about an active intake. We've kind of jumped straight to what that might look like. But as we're going through our prototyping process, we don't try and limit ourselves just to looking at one particular type of intake. We might have a suspicion that something is better for an active intake. But what we're trying to do is keep an open mind, because if we design some particular types of intakes like what Nick's about to show, while it might not be great for using it as an intake, but it might give us some insight into how particular materials move or how the artifacts are handled and that kind of stuff. So I know you've got like this claw in your hand, Nick. What's the sort of thinking? Is it to pick it up? Is it to do something else, or is it just for general learning?
So one of our members, Ryan over here, actually prototyped this as a potential intake. So Ryan, if you can demonstrate it, I can talk about it. So what it would be is it would be a passive claw. So the wheels are actually locked down. So what would happen is they would apply a lot, I'm assuming, of downwards force onto the ball, and it would clamp based on the wheels. But as you can see, we tested it a bit, and it's not very effective in holding the ball, because it just slips out, and it requires a lot of force to actually get in. So yeah, but a key learning from this is that this could be used in other aspects of the robot, like to shift things around or to move the artifacts around in the robot. So yeah, it was a good learning for us.
So even though it wasn't quite used as Nick suggested, potentially for an intake, it does give insights into what might be required to move those artifacts around inside your robot as a transfer mechanism. Yeah.
Some of the intakes that could be used for this year's game, but probably isn't as recommended, is the claw intakes. So yeah, because usually the claws could be, especially for this year's game, when you drive up to the artifact, you could kind of roll the artifact along, so it's difficult to kind of pick it up. But there's also the indexing it into the little holes. That could also be an option, but like some of our experiments shows that it isn't. But just trying different ways of the intaking could lead to further ideas along.
Yep, excellent. All right, so if no more questions so far, we'll keep working our way down the robot a little bit more. So I guess when it comes down to it, you need your robot to be able to move around the field. So we've got a couple of different options. Our thinking so far has been that this is going to be a speed game. We think that you're really going to have to get around and be quite quick. If you're fast enough, then you can get more artifacts picked up and launched in. So what do we got here, guys? Who wants to have a go? Do you want to have a go describing at least what the components are, Rylan?
We got some Mecanum wheels. Yeah, 140 Mecanum wheels.
So the really big guys, yep.
Yeah, that will let you move faster than the usual. What are the usual?
96 or
96. Yeah, they'll let you move a lot faster than usual, so you can cycle faster, I guess. And then you got some motors on top, 435s, connected to the control hub just to power the wheels. And then it will let you move around. That's
excellent. All right, so we've got the large Mecanum wheels, the 435. So typically we don't usually see the larger Mecanum wheels. The reason why is because the robots do typically go a little bit faster, a little bit harder to control in auto and that kind of thing. You've got more comments? Yep.
So one thing you will notice with these, we've had to mount the motors on the top here. It's because the size of the wheels in typical strafer chassis construction would actually mean that the robot wouldn't fit into the base zone. So keep that in mind if you're using the bigger Mecanum wheels. You have to make sure your motors, 2 of them, are mounted on top.
Excellent. All right. Yeah, so obviously the idea is to go for maximum speed. So that's probably about the best speed that we could get, I guess, while still managing the power draw. Obviously, you could, if you were to put, say, 1100 RPM motors on the robot, you get to the point where you're starting to draw a lot of current, and you're not really moving, you're browning out. So there's a compromise somewhere in there. I think the Swift wheels, the new ones, are around 500 RPM or so. they're probably pushing the limit of where you could go with it, and this is probably giving you probably roughly about the same sort of speed as well, I think. Obviously, this year, what do we think? You know, a lot of teams have got Mechanums, but not everyone's got a Mechanum. And if ever there was a year to have a tank drive, it'd probably be this year. Do we agree that we might go around again and get everyone's opinion on what they think a tank drive could do this year? I know we're certainly worried about tank drives. I think that, yeah, there's a lot of potential there.
Yeah. So again, it is kind of a big question, Mechanum or tank drive. This year, tank drive is again pretty viable. If you actually have seen some of the videos of the robot prototypes, if you're able to launch, load your robot like this, and then you can just drive straight forward and not even turn, and then fire straight into the goal like that, and then just repeating this cycle of back and forth, and which is really good if you have tank drive, because you're just going to not really be turning. Again, yesterday, I think there was talked a little bit about strategy and maybe about defense a little bit. With the tank drive, it's going to be a lot harder to be pushed around, so you won't get your shots as defended as much. So, for example, if you're sitting in the launch zone and you get bumped, you won't move as much, and you can still try get that artifact to go into the goal. So I do think tank drive is pretty good. Also be pretty fast as well. So.
I'll jump in.
Question.
Question, and we'll pick back that up in a second. The question was, is there a specific surgical tubing product from Surgical Direct that you would, someone just lost that, yep, I would recommend for our intakes? There's quite a variety of tubing. Yeah, there is. We've got, yeah, it's I think it's a 10 and 8. I'll tell you what, I'll find the exact product number in a second, and I'll get someone to put it in the chat. But yeah. Yeah, good question. Yeah, there is a lot. There's a lot of different varieties.
It's the different surgical tubing may also, like, that may not be the perfect surgical tubing for you. Like, you may want a different inner diameter and an outer diameter, so it's more compliant. So that's one thing that you may also want. Like, this one was good for our center stage surgical tubing, so to bring in the pixels. This one could be a little too compliant or a little too stiff to bring in the artifacts. It also depends on the kind of experimenting with it. So different intakes will have different, like, it'll work better depending on the surgical tubing. So do we want to move on to back to the
yeah, let's go back to
the
let's go back and get
talk.
everyone's ideas on tank versus Mechanum for this season.
So yeah, my personal view on tank versus Mechanum. Mechanum is viable as it always is, but I think this season tank is still very viable, especially because there is a very limited amount of protected zones on this field for each alliance. So a tank drive robot is much harder to be pushed around, especially sideways, than your regular Mechanum robot because of the rollers. So yeah, tank is viable, especially because of that defense aspect.
Yeah, as Nick said, it's harder to get pushed around, so and I think that tank drive is a lot more viable than it has been in like the last few seasons. Mechanum is still pretty viable though, so yeah.
Yeah, Mechanum might just get you that extra maneuverability as usual, but yeah, as everyone's been saying, tank drive a little harder to defend. You can't get pushed around as much, which is very valuable when you're trying to get a very accurate, precise shot from like pretty far distances sometimes in the further launch zone.
With what Ryan said earlier, with the moving from the human player, the loading zone to the launch triangle, is really good to just be able to move backwards and forwards. And considering there's no terrain, makes it a whole lot more viable, so that the robots don't have to climb over anything.
In some cases, the tank drive could also have the same maneuverability as the Mechanums if you have like the aiming turret and the aiming launcher. So that could be the way your team wants to go. But I think Mechanums are still probably the best method to traverse the field. With this one over here, though, with the bigger Mechanums, you may have a issue with your autos and your accuracy with it. But if it's a human player robot, you may want to have that compromise with the speed so that you can just launch your preloads and then move off the line. So that's just depending on what your team wants to do as well.
Awesome. Yeah, and I guess typically for a tank drive, what you'd be looking at in normal seasons is a 20-to-1 gear ratio. So if you're using the Rev kit, that's the 5 and the 4 cartridge. So if you think about a Mecanum is normally around the 12 to 1 is kind of where you go with. So, but you have to consider that when comparing the tank to the Mecanum has four motors, so there's a little bit more overall output, power output. You can probably go down to what the 4 and the 3 to 12. You'd have to test it. You'd have to test to see how much weight your robot is. I think you probably get to see a little bit of power draw issues, and I think you'd see your robot get bogged down again. And then you could go the 3 and the 5 to 15, which would probably be a pretty good compromise again as well. So it's worth experimenting with and trying to get the speed out as much as you can. It looks like we've dropped the actual tubing into the chat, so that's the one that we've purchased, and we've used that for center stage, and we've been doing, I think, a little bit of prototyping with that as well. That surgical tubing that Andrew showed you, so that's the stuff that we got. So I think yeah, so that's the Mecanum base. We've got the tank base as well. You know, we always like the Mecanum for ourselves. That's just something that we've always been lucky enough to have. What other elements are we looking at here that we can see? The base park. So obviously, you know, I guess we're talking a bit of the strategy again. Being able to try and fit inside the box as best you can. And this is a really good challenge because, you know, holding, as you saw before, holding 3 of these artifacts, depending on your configuration, you're going to need a wide base. You know, I think my gut feel says it's not really that worth worrying about trying to park this. Like, you know, we discussed yesterday that it's still possible to get the ranking point. It's quite easy to get the ranking point if both robots leave the zone in auto. And I think if you're going to spend some effort on the autonomous. We do have a bit of a theory that I think by the time the World Championship comes around, most of the robots are going to be kind of hanging up and doing a little bit of a pill. Yeah, show what we think will happen. I don't, you know. So basically, we think that they might put some little feet down and just sort of do like a little pivot and hang over the edge. So you might have seen some of the robots in Into the Deep. William says Road to D2 was one of the ones who kind of, they tilt their robot back to try and make contact with the what were they called, the level 1 and the level 2. Yep, to get to the level 3. So that mechanism would probably work quite well, just tilting the robot up. I guess you want to talk? Yeah.
The problem with that though is both alliance partners need to kind of have that mechanism. So you could develop the mechanism for it, but if your alliance partner doesn't have the same similar mechanism, you can't really. It's not very effective for that. The extra 15 points for the inside of the park. So it's really dependent on what your alliance partner is doing with that mechanism.
Yeah, absolutely. Yeah, so you got to also take into consideration there's the horizontal constraints this time. So putting little feet down outside of your robot and that kind of stuff has to be within the bounding box. So you know, putting something like, if you're thinking some of our teams very inspired by FRC teams, so things like Citrus Circuits being able to do like a little handstand on someone is you know, is something that we would consider, but it's not going to be within the realms. The boys are sort of showing, well, you know, you can kind of potentially kind of drag another robot up on top of you, but I mean, we're looking at a robot here that's sort of a prototype that's a little bit flat. You're going to have turrets and launchers and all that kind of stuff on the top. So yeah, there's considerations with that.
If any of you have watched the robot in 30 hours, some of them have actually had stilts on their robot. So one of them lifts up like above the other, like above, like exactly how Nick is showing there. If you have a tall robot, that could be like, that would have a high center of you want a lower center of gravity so you don't topple over.
Yeah, and we've also seen videos. The boys are telling me about, you know, having plates and platforms, particularly the Coach Pratt video where you know, he's pushing into the bottom with a support and kind of raising the whole robot up so another robot can drive in. A lot of effort to go to for that sort of stuff, yeah.
And probably with that one, you're increasing the weight of your robot. So if you are trying to go for that speed, that for those quick launches, it may having extra type of pushing down could increase your weight. but it's up to the teams of what they want to kind of go with. And sometimes it could cantilever if you have a support as well.
I guess moving on to some of the other kinds of topics that you might be considering as part of your robot build this season. Oh, okay. Yep. What I was going to suggest is that some of the other sensors that you might look at using this season are our color sensor. We've got another question. What does your team think about a community design hook system where robots hook together at the top and then they can drive apart? Well, that's interesting. What do you guys think of that? So I'm thinking the parallels would be a couple of years ago, Barker used to walk around with an attachment that you could attach onto your robot that worked with their particular hook and climbing system, so something like that. So I guess you'd have, if it was something that, oh, he means like that, does he? Sorry, okay, all right. You guys know more than me. Here you go.
Yeah, I think it would be really cool if we could see the community kind of like completely solve the first design committee's challenge by just having everyone have the same thing on their robot. I think it'd be really cool. I think for us personally in Australia, we would love to do that, but we have a very short season, so a lot of teams probably wouldn't have been able to see if that is actually viable yet, because we are actually one of the first competitions that occur in the season. But I think as the season progresses, if we see teams actually implementing the design, you could kind of see by the World Championship, everyone just having the same hooks. I think it would be really interesting to see that, and I think it'd actually be pretty cool. Completely solving the game, but we'll see how it goes.
Yeah, great question. Yeah. All right. So getting back to it, some of the other little prototyping that we've done. The person who I worked with yesterday isn't here for this, so I'll kind of elaborate. But basically, we were starting to look at the challenges with sensing the color from the artifact. So you might have noticed the artifacts have some holes in them. So it's completely conceivable that the artifact can land in a position where it's challenging for your sensor to be able to take a reading. So the hue and the saturation and the RGB and all that kind of stuff can be measured, and really well, there's a lot of differences between the two types of artifacts. So when you do get it landing on a spot, it's actually quite easy to tell the two apart. But depending on how it lands, you could conceivably get your sensor into a gap or a trough that doesn't quite give you the same reading. So be interesting to see how people approach that problem. Something that we'll have to do a little bit more prototyping on. We're looking at different ways of illuminating. So you can see we've got one of the Go Builder headlamps. So we're looking at trying to tackle it from an illumination point of view. We're not sort of ready to, I guess, release any results on that because we haven't got them yet, but that's sort of an active area of inquest for us. Obviously, distance sensors are good at detecting whether artifacts come into an intake or not. Those are probably the two that I think we've looked at the most in terms of our electronic side of things. Encoders are always needed. Well, I guess there's an interesting discussion. You've got a turret. You really need to know the position of that turret, so it's a good time to brush up on your motor encoder skills, understanding what the gear ratios are and what each revolution of a motor goes to, and how much your turret moves in terms of degrees. Good amount of math that you guys can look at for control awards and that kind of thing. Put it out there, guys. If you've got any questions, drop them in now.
Do you think the other thing that could be a useful thing to have, especially if you're going with the human player robots, is a way to plow like three artifacts into the human player zone, and also for the depot, just in case for a quick kind of extra bit of cycles at the end. Because if you're the human player robot and the other team hasn't been releasing the gate, you'll have to push the artifacts into the human player loading zone so that you can kind of load them in yourself. So that's something to also consider when designing one of those human player robots, is you'll need a way to kind of travel and push the three artifacts to the human player to put them in.
Yeah, great choice. Yeah, good design choice. Any more questions coming up? Nothing over here at the moment. got a question?
One thing to mention, so to keep in mind, trying to have flat walls on the side of your robot instead of having like your mechanisms and your wheels on the outside not covered, because you do have to hit the side of the gate to release it all, and if you collide with your wheels, you could potentially damage them.
Actually, that's a really good point. So a couple of years ago, we took a robot to a public demonstration where the public could drive one of our Mecanum robots around, and probably after about 2 hours, we probably had about 3 or 4 of the Go Builder Mecanum wheels with their E-clips all spread across the fields, the rollers coming out. They don't really like being beaten up pretty badly. So in a defense-heavy game, you know, you probably do want to give those wheels a little bit of protection. So that's definitely something to consider. Yeah.
Do we also want to talk about what applications servos could be used for this year?
Yeah, absolutely. What have you got?
So yeah, I think that this year's game is probably a motor-heavy game, so that the motors are probably more important than the servos. Last year, you could have used more up to the servo limit, but as the servo limit has changed, I think that the most important ones are to probably for your hooded launcher, so you can change your angle. Or Ryan, would you like to add on to anything with it? Servos?
Yeah, so the other servos you could use are kind of how you could feed the artifacts into your launcher, ready to fire it. Like I said, like Will said, there's not really many things I can think about to use servos for, because you're mostly going to be wanting to use fast motors to be powering your elements. So example, if you want to build a turret, you should probably be using a motor for that. All of your wheels, you should be using motors. Your launcher has to be using a very fast motor. And your intakes, that's where you can actually kind of decide, do I want to use a servo or do I want to use a motor for that one as well? The difference, of course, being the speed of how fast you can intake those artifacts into your robot. The motor being substantially faster, but also a lot heavier.
Yeah, well said. I think 2 of our mentors here were around in the power play region or game area, and we used a servo for a turret for I think for our nationals robot. Do you guys remember some of the issues that we had with the servo?
Yes, there was many issues. There's many issues. The main issue though was when you were going for the high junction, the servo was like it used to go past it and had a little bit of what is it called, backdrive or backlash? Is that what it's?
It had a. I guess the way the servo works is it's got an internal PID, so it's trying to hold its position, and it's kind of those PID weights are generally based around, you know, its normal loading conditions. But what we found with a turret that had an end effector on it, when the servo spun the turret around, the momentum kind of kept pushing the servo, and what happens is it kind of oscillated as it tried to find that nice little range where its PID would be most effective. So what we found is, basically we got a whole lot of oscillation out of the servos because they weren't quite tuned. And with servos, it's a little bit harder to tune those PIDs. Some of the newer servos that we get from Axon and some of the other high-end servos, you can do some configuration to dampen them and do things like that. So it might be possible to get them out. You can absolutely do that. The other option, again, is if with some of the higher-end servos is to use them in continuous mode. The problem with continuous mode is the delays that kind of creep into them. So it's the same problem that we see with teams using continuous servos with swerve. They're just not as responsive as you need them to be. Maybe that might change with the Axon Mark IIs that have got swerve mode. Maybe it's not really the swerve mode. Maybe it's going to be the turret mode that makes them work a little bit better. I don't know. We don't have access to any of those sort of things, but interesting observation if you're thinking about using a servo for powering your turret. If it's got a bit of weight behind it, you might have a little bit of trouble. Sorry? Cable management, I guess, yeah. So that's a really interesting one. You guys have been bitten from that before with the turret. Definitely, I guess, anything that can spin, particularly something that can spin more than, almost 100 or 360 degrees, you're going to have to think about how your cables come through. Typically, with a turret, you're going to run the cables through the center, but obviously, if we're trying to put an artifact through the center of of our turret, that's not going to work too well this year. So you're going to have some kind of way to manage the cabling. If you kind of look at an FRC robot for inspiration, they have what they call like energy chains. So the energy chains are largely the cable drags that you see on 3D printers or on CNC machines that kind of hold the cabling in a nice way, and they kind of unwrap and wrap in linearly. But you really need to think about what that packaging might look like in your robot so that you can wrap it around and run it around your turret as best you can. So, but definitely you can get yourself into a whole lot of trouble with cable management if you're not careful. Anyone want to add to that, or you feel like that's okay? We're good? Yep. No more questions so far? You got one thing? Yep.
When doing your testing, if you're using a turret, make sure you don't overspin it if you have cables going through, because if you spin it too many degrees, it will probably snap your cables, and that will be a nightmare to fix up.
So yeah, getting back to it, using those encoders to do some wraparound testing and that kind of stuff to make sure that your turret's not going too far. All right. I think we're kind of getting to the point where we're stretching for some content. If there's anything else that you guys want, we'll sort of hold the lines open for another minute or so that you could drop us some questions and we can try and answer in real time. But we're always happy to answer questions, so feel free just to send us an email. We'll do our best to get hold of things. Yeah, if you've seen any parts or you want to know what kind of things that we've used, you can just drop us a note.
If you're wanting to find like ideas for holders for the artifacts and for launches, use past FRC robots. They tend to do. They actually used those artifacts in 2017, having to hold them. So FRC games are really useful for any ideas.
And there's we got a question. What can you use the lazy bearings for, and are they useful? So basically, looking at them, if we want to come back to this robot again, where'd the bearing go? Oh, over here. Here we go. So so imagine that's the way. Good job. Yeah. So it sits on top of the lazy Susan bearing. So basically, we can spin this around and always point it at the goal. So hopefully the boys can. So that's turning, and imagine our shooter is on top of that. Yep. Fantastic. All right. Are there any ways to move the artifacts around inside the robot to match the patterns? So, given, I guess, looking at those packaging constraints that we looked at before, you're probably better off trying to get the artifacts into the robot in a stable position and then use sensors to try and work out which ones are in which positions. I think you probably have better luck doing that than trying to move them around. I think given the space constraints, that would be my advice. Does anyone want to add any comments to that? You guys?
Yeah, there's lots of different ways teams could go around, I guess, sorting the colors. If you're doing it from a human loading side of things, that's going to be all right because the human can actually load it in the color that you want. Even during regular tele-op, since the driver can drive around and, let's say, intake off the ground any color artifact, then they can also intake that in the correct order. The only problem is if you want to do order and you want to do high level orders with correct motif pattern during order, then that's when you would want to be able to individually fire or move the artifacts in a way that you can choose which one is fired next. There are lots of different ways. The most popular one that we've been seeing currently is what's called a spindexer, as in it can index the balls by spinning. That can consist of kind of what Nick's showing here, where the three artifacts rotate. For example, maybe there's a divider that can rotate them from the middle, and then somehow you'll be able to choose which one of those to launch out of your robot. Other options include you would have to use color sensors and able to detect which color it is.
Thanks, Ryan. Yeah, yeah, good questions. And these are some of the challenges that we're still trying to come to grips with, trying to understand how to best hold these artifacts. And what the trade-off is. If you can't sort them quickly, then you probably have to ask yourself, is it really worth it? Is it worth compromising your teleop just so that you can get a sortable auto? Those are the things that your team can kind of answer. Anything?
Something else to note is if you have something like this in this configuration and you have servers that can launch individually, you'll actually already know which order they are in, especially for your preloads, so you can make sure you can get that motif if you have a set position for what color is in what segment.
Yeah. Awesome. Okay. That was a really good question. Oh, we got another one. Do we have any more advice for cable management? Okay. So what we've done in the past is GoBuilder have got some really good. It's kind of collapsible. No, it's kind of like, we call it snake skin, but that's probably not going to be the correct term. But it's the sheathing, but it's kind of got it's got supports in it, so that it really wants to hold on to the yeah, it's really got a. I'm just trying to think of the words. It really collapses on itself, and it's quite thin. I think it's like a 6 or 8 mil. Yeah, potentially. I think. Oh, Ryan's over there getting it. Yeah. So that's really good. If you're thinking about cables going through any kind of channel, we can probably get a shot of this, but you really want to make sure everything goes through a grommet, because over time the cables will wear on the aluminium, and it will cause it to fray. So these are little grommets, again, that go through the GoBuilder channel. Really good. And we got a shot of the. Sorry, yep, we got a shot of the. Okay. And then, yeah, zip ties. But make sure, if you're zip tying things down, make sure you kind of give them a bit of a tug. Make sure that things aren't pulled too tightly, because if they're too tight, then they're going to basically pull out of their connectors and that sort of stuff. So always give them a nice amount of, movement, slack, yep. What do I mean by compromising the teleop with the sorting system? Well, I guess by that I mean if you've built your robot around being able to sort, but it takes your robot a second or two longer to be able to pick up and index your artifacts, then you're losing a second or two every time you cycle. Over a game, that might be 10, 15 seconds. That might be 4 or 5 cycles. So.
To also add on to that is the sorting is only a small aspect of it. So the sorting can only really be done in auto and at the end of teleop. So you get most of your points based on throughout the teleop phase, and most of the time you don't need to sort during that time. So it's really, if you have a really good sorter, that's good. But if you have a very slow sorter, that's probably not as good as it, and it's slowing your launches down and your cycles down. It's probably better to go for a faster cycle robot instead of the sorting.
Yeah, that would be my advice. Hopefully that answers what you're looking for. No, we've got about three or so more minutes. We're just sort of going through the questions. That's all right. I think. Yeah, Andrew's just mentioning that there's different options around soldering versus using extenders and that kind of thing. Each team has their own different preferences. We're more of a soldering team, but some teams are using connectors and expanders and that sort of stuff. But that's more of a personal preference. And William's all about weight, so he thinks that anything that can save a few grams is always good. Yeah. Outside of that, I think we. Pretty good in terms of time. We've got another workshop coming up in another week or two, I think, where we'll obviously our understanding of the game will be a little bit different potentially then. We'll have some more ideas. Obviously, the caveat with today is we're going on the information that as we understand it. Make sure if you're trying to make any decisions, make sure that you sort of verify that, particularly with the game updates. We're doing the best that we can with what we know. And hopefully we've given you some advice that you can action and use. But other than that, we're going to thank you guys for spending your morning with us, or your evening, or your middle of your night, wherever it might be. I'll just hand around just one more time so the guys can say goodbye.
Yeah, thanks for rocking up. See you next time.
Yep. Thank you. Good luck for the rest of your season.
Thanks for listening. Yeah, good luck on your games.
Yeah. Thank you for watching. We'll see you next week.
Hopefully some of these ideas helped you kind of flesh out some of your ideas potentially. And thank you for showing up. I know it's different time zones, so again, thank you very much.
If you thank you for joining us, and if you have any questions, just send them through.
Awesome. All right, guys, thanks again, and we'll see you soon. If we don't see you, good luck.